Until 20,000 years ago, there was nothing on this continent belonging to humanity. Not the smallest trace of it has ever been found. Everywhere from the north of Alaska to the tip of Florida has been searched and examined, and nothing has turned up. People were not living on this land, but other animals were, and there were more large animals here than there are in Africa today. Elephants in the forests of Ohio, lions in the sagebrush of Wyoming, bears in Alaska, and those bears were so large that even grizzlies looked ordinary beside them. In the trees of Missouri, there were enormous animals that weighed almost as much as a car, and these giant sloths fed on leaves. And in Nevada, there were camels. This was a continent no human being ever saw, and today the great majority of it is gone. In this video, we are going to examine that America region by region, one at a time. We will start in the north, move down to the plains, then into the eastern forests and the warm south, and we will get to know the animals that lived in each of them. And at the end, we will explain why these animals disappeared. In the space of just a few thousand years, most of these animals in North America were gone, and all of it happened on the same quiet ground we are living on today. If you also enjoy learning about the animals that once lived where you live and then vanished, you can subscribe. It only takes a few seconds. Now let's get to know these animals together. Before we go anywhere, it helps to fix a few things in your mind, because the America of 20,000 years ago operated by rules that no longer apply anywhere on this continent. The first rule is that everything was bigger. Not everything, obviously, but the animals that define the landscape, the ones you would have noticed, were consistently larger than their modern equivalents, and in many cases they had no modern equivalents at all. And this was not unusual for the planet at that moment. Large animals were the normal condition of the Earth's continents until very recently. Africa is not exceptional today because Africa built something special. Africa is exceptional because Africa kept what everywhere else lost. North America had its own version of that abundance, and it was arguably richer. Scientists have a word for this, Megafauna, which simply means large animals, and the working definition is any land animal over about 100 pounds or 44 kilograms. By that measure, North America carried an extraordinary roster: multiple species of elephant, several kinds of giant ground sloth, one of them reaching the size of a modern elephant, armored mammals the size of small cars, native horses and camels in large herds, giant beavers, a stag moose, bison substantially larger than the ones that survive, and a full suite of predators to work on all of it. It is worth naming a few of them now because they will keep appearing as we travel: a saber-toothed cat, a lion larger than any alive, a bear that dwarfed the grizzly, a wolf heavier than any wolf today, and a cat built for running down fast prey. All of these existed simultaneously, on the same continent in overlapping ranges. The second rule is that the climate was different, and that difference shaped everything else. This was the late Pleistocene, the last stretch of the Great Ice Age, and enormous ice sheets covered most of Canada and reached down into the northern United States. The world was colder and crucially drier. Sea levels were far lower because so much water was locked in ice, which meant coastlines sat well out from where they are now, and Alaska was connected to Siberia by a broad plain of dry land. That last detail matters more than it sounds, because it means North America was not an isolated island during this period. It had a door at the top, and animals came through it in both directions across hundreds of thousands of years. Much of what we think of as characteristically American wildlife, the bison above all, walked in from Asia through that opening. The third rule follows from the second, and it is the one people find hardest to picture. The vegetation was not what grows here now. In the far north, there was an ecosystem called the mammoth steppe, a productive mixture of grasses and hardy plants stretching across the unglaciated northern hemisphere, and it has no modern equivalent anywhere on Earth. It was not tundra. Tundra is wet, boggy, and poor. The mammoth steppe was dry, relatively fertile. and it supported grazing herds in numbers that the same ground cannot begin to support today. Further south, the picture was a patchwork rather than the neat vegetation zones we are used to. Spruce forest grew where hardwoods grow now. Grassland pushed into areas that are woodland today. Species that no longer occur together lived side by side in combinations ecologists call non-analog communities, meaning literally that there is nothing like them anywhere in the modern world. If you want an honest summary, it is this. You could not walk into Ice Age North America and recognize the plants any more easily than you could recognize the animals. This is one of the reasons reconstructing these landscapes is difficult, and also one of the reasons the reconstructions are so interesting. Paleoecologists work largely from pollen preserved in lake sediments and bogs, counting grains layer by layer to establish which plants grew where and when. It is painstaking work, and it produces a picture that consistently refuses to match anything living. The fourth rule is about density and behavior. When a landscape carries very large herbivores in numbers, those animals reshape it constantly. Elephants knock down trees and open clearings. Large grazers crop grass and keep woody plants in check. Enormous animals trample, dig, wallow, and move seeds across huge distances in their guts and on their hides. The vegetation of that continent was not simply a backdrop that the animals lived in. It was, to a significant degree, a product of what those animals were doing to it every day. Ecologists call animals that play this kind of structural role keystone species, and elephants are the standard modern example. An African savanna with elephants and one without are visibly different places within a few decades. Now multiply that by several species of elephant, several species of giant sloth, and enormous herds of grazers, and you begin to appreciate that the Ice Age American landscape was being actively maintained by its own animals. And the fifth rule, which changes the emotional temperature of everything that follows, is the one in the title. There were no people. That is not a small detail. Every landscape on Earth today, including the ones we call wilderness, has been shaped by human presence for thousands of years. The America we are about to visit had never seen a human being, never heard a human voice, never had a fire lit by a human hand. It had been running without us for millions of years, and it would go on doing so for several thousand more before the first people walked down from the north. There is something clarifying about that. Every account of American wilderness that we tell ourselves involves people somewhere in it, whether as observers, as inhabitants, or as the ones who arrived and changed things. This is the one chapter that has nobody in it. For the entire duration of what follows, until the very end, there is no witness. And that absence is the reason this account can only be assembled indirectly. Everything in it comes from bones in gravel pits, pollen in lake mud, chemical signatures locked in tooth enamel, and genetic material recovered from frozen ground. It is a reconstruction, built piece by piece over about 2 centuries of work, of a world that produced no record of itself except its own remains. So hold that in mind as we go. A colder, drier, stranger continent covered in vegetation you would not recognize, carrying an enormous weight of very large animals entirely unobserved. We are going to start where the land was hardest at the top of the map and work our way south. And as we go, I would encourage you to do one thing: find your own state. Whatever part of this continent you are sitting in, it appears somewhere in what follows, and the animals that lived there are not a general abstraction. They walked on the specific ground you know. That is the difference between this and a general documentary about prehistoric life. This is not about a distant place with an exotic name. It is about Ohio, Nebraska, Florida, California, and the rest. And the answer to the question of whether something remarkable once lived where you live is almost certainly yes. Start in Alaska, because in the Ice Age, Alaska was not the end of anything. It was the middle. With sea levels hundreds of feet lower than today, the shallow sea between Alaska and Siberia was dry land, a broad grassy plain that geologists call the Bering Land Bridge. Alaska, the Yukon, and eastern Siberia formed one continuous region known as Beringia, and remarkably, most of it was never glaciated. While ice sheets buried Canada, this far northern country stayed open. That produces a geography that feels backwards. Most Americans picture Alaska as the frozen extremity of the continent and the lower 48 as the habitable part. In the Ice Age, it was closer to the reverse in one important respect. A great deal of Canada was under a mile of ice and completely uninhabitable, while Alaska was open grassland teeming with animals. The map of where life was possible looked nothing like the map we carry in our heads. The reason is counterintuitive. It was too dry to build glaciers. With so much water locked into ice elsewhere and the climate strongly continental, Beringia had low precipitation and clear skies. What grew there was the mammoth steppe, and the animals it supported were extraordinary in both number and size. This was the heartland of the Ice Age, the richest large animal community in the northern world, and it was not a fragile or marginal system. It persisted through several glacial and interglacial cycles, meaning it survived repeated swings of the climate over hundreds of thousands of years. Whatever eventually destroyed it, it was not the ordinary variation that this ecosystem had already absorbed many times. That point deserves emphasis because it constrains the explanations. Any account of why the mammoth steppe collapsed has to explain why it collapsed at the end of the last glaciation and not at the end of the several previous ones. The system had been through this cycle before and had come out the other side intact. Something about the most recent transition was different, and the leading candidate for what was different is us. The woolly mammoth is the animal everyone pictures, and here it belongs. This was its home country, shaggy, cold-adapted with a dense double coat, small ears that lost less heat, and a layer of fat beneath the skin. But the mammoth was not the most numerous animal on that landscape. Studies of fossil abundance across Beringia show that in interior Alaska, bison dominated, followed by horses, with mammoth third. In northern Alaska, horses were most common, then bison, then caribou. These were not scattered survivors. These were grazing herds on open ground, in the sort of numbers that the Serengeti carries. And the composition varied by region, which is a good reminder that Beringia was not one uniform place but a mosaic of different ecosystems. Interior Alaska was bison country. Northern Alaska was horse country. Siberia had more caribou. Each of those differences reflects real variation in soil, moisture, vegetation, and snow depth across an enormous area, exactly as you would expect from a functioning continental system, rather than a single monotonous plain. Yes, horses. Native American horses, of a kind smaller than the ones we know, grazing the northern plains in large numbers long before any Spanish ship arrived. And the steppe bison, ancestor to the modern plains bison, was here too, larger and heavier than its descendant. Add to those the caribou, which still survives, and Siberian and Alaskan populations of cattle-like animals similar to modern yak, and you begin to see the shape of it. A cold, dry, wind-scoured grassland supporting an enormous quantity of grazing meat, which of course attracted the appropriate predators. The cave lion ranged across this northern world, a great maneless cat closely related to the American lion further south. Radiocarbon evidence from Alaska suggests these lions may have specialized in hunting horses. There were wolves, larger and more powerfully built than modern gray wolves. And there was Arctodus, the giant short-faced bear, an animal roughly 30% larger than a grizzly, standing 11 or 12 feet tall when it reared up, with legs long enough to suggest it covered ground efficiently across open country. What Arctodus actually did with those legs is still argued over. Some researchers have pictured it running down prey across the steppe. Others think it was primarily a scavenger using its size to drive other predators off their kills. Others suggest a more flexible omnivore. What is not in doubt is the size. Standing on all fours, it looked a tall man in the eye, and when it rose onto its hind legs, it was well over 11 feet. There is something particular about picturing this landscape, and it comes from the light. Beringia sat at high latitude, which means the winters were dark and the summers had nights that barely arrived. Imagine a July at 2 in the morning, the sun sitting low but not setting, and a horizon of open grass with mammoth and bison and horse moving across it in the long amber light, and lions somewhere in the middle distance. That happened on ground that is now inside the United States, and no human being ever saw it. That is worth repeating because it is the strangest fact in this entire account. Everything we know about that scene comes from bones, from pollen, from chemical traces in teeth, and from ancient DNA. There is no eyewitness, no oral tradition, no memory of it anywhere in human culture. It is a functioning world richly documented by science that no consciousness ever experienced. And that is true of almost the entire span we are covering. People do eventually arrive, somewhere around 15 to 20,000 years ago, depending on which evidence you find most convincing, and the last chapter of this world does have human witnesses in it. But for the overwhelming majority of the time these animals existed on this continent, nobody was watching. They lived and died for hundreds of thousands of years in complete privacy. The mammoth steppe also tells us something important about how these systems work, because when it went completely. Today the same country is covered in permafrost, peat, spongy tundra, and boreal forest. It is buried in snow for half the year and swarming with mosquitoes in a cool, wet summer, and it supports a small fraction of the animals it once did. The soils point in the same direction as the vegetation. Pleistocene Beringian soils were drier, warmer, and more fertile than the waterlogged, acidic, permanently frozen ground that covers the same country now. Fertile soil grows nutritious plants. Nutritious plants support grazers. Grazers support predators. When the soil changed, the entire structure above it lost its foundation, and no amount of protecting the surviving animals could have rebuilt what was gone. The soils are different. The vegetation is different. Researchers describe the mammoth steppe as a biome with no modern analog, meaning it is not that we have less of it, but that we have none of it at all. And the loss was not only animals. Recent work using ancient plant DNA from Siberian and Alaskan lake sediments has begun to detect plant extinctions tracking alongside the megafauna losses at the end of the Pleistocene, with major events around 17,000 and 9,000 years ago. When the mammoth steppe collapsed, it took part of its own flora with it. What replaced it is what you fly over today on the way to Anchorage, and it is a much quieter country. There is one small consolation in the north, though, and it is a real one. Because Beringian ground is cold and often frozen, it preserves organic material extraordinarily well. Alaska and the Yukon produce mammoth tissue, hair, and ancient DNA of a quality that temperate sites cannot match. The country that lost the most is also the country that kept the best record of what it lost. Come south now, down the western half of the continent, into the country that runs from Montana and the Dakotas through Nebraska and Kansas into Texas and New Mexico. This is the American interior, and in the Ice Age it was the richest large animal landscape on the continent. If there is one region where a modern American can most usefully be told that the ground beneath them used to look like Africa, it is here. The comparison is not loose either. In terms of the number of large mammal species, the size of those species, and the density of predators sitting on top of them, the Ice Age American interior was in the same category as the great African savannas and quite possibly exceeded them. A traveler who somehow visited both would not have described them as similar landscapes, but they would have recognized the same fundamental abundance. The dominant elephant was not the woolly mammoth, but its larger and less hairy relative, the Columbian mammoth, standing around 13 feet at the shoulder and weighing close to 10 tons. It ranged from the northern United States down into Mexico, and it was a grazer, working the grasslands with teeth built like grinding mills. Where the ranges of woolly and Columbian mammoths overlapped in a band across the middle of the continent, the two interbred, which we know from their genetics. It is worth stressing how strange that overlap zone must have looked. Across a broad band of the middle of the continent, you could have seen two different species of elephant in the same country. The huge, relatively hairless Columbian mammoth of the grasslands and the shaggier woolly mammoth pushing down from the north. And in the wooded eastern margins, a third proboscidean entirely, the mastodon, which was not closely related to either of them. Around them moved the herds, native horses in numbers and variety, grazing the same country that would be empty of horses for 10,000 years until Europeans brought them back. Camels, which is one of the details that surprises people most, but camels evolved in North America before they ever reached Asia or Africa, and there were tall, long-legged camels on the American plains for millions of years. Bison, larger than today's. Pronghorn, already the fastest animal on the continent. And in the wooded margins, deer and a large stag moose with strangely palmate antlers. Put all of that together into a single view. A herd of Columbian mammoths moving across open grass, horses grazing in the middle distance, camels browsing at the edge of a stand of trees, bison in the hundreds, pronghorn scattered across the plain, watching everything. That is a scene from Nebraska, not from Kenya, and it played out for hundreds of thousands of years. Predators on that scale of prey were correspondingly serious. The American lion, Panthera atrox, hunted here, and it was roughly 25% larger than the biggest African lions alive today, which makes it one of the largest cats that has ever existed. Dire wolves ran in packs across the same ground, heavier and more powerfully built than gray wolves, with a range that reached from Canada to South America. The American cheetah, a long-legged running cat that was not actually a cheetah but a relative of the cougar, pursued fast prey across the open. And the short-faced bear was here too. Think about what that means for a single herd of horses standing in what is now Wyoming. On any given day, they were within range of a giant lion, a pack of dire wolves, a running cat built for pursuit, and a bear the size of a small car. There has been no comparable predator community anywhere in North America since, and it is worth being precise about what that would have meant on the ground. A modern pronghorn faces coyotes, which top out around 40 miles an hour. An Ice Age pronghorn faced a running cat, a giant lion, a pack-hunting wolf, and an enormous bear, all in the same landscape. The margin for error was not small. Every animal in that picture lived under a level of threat that has no modern equivalent on this continent. The pressure on prey animals must have been continuous, and it shows in the survivors. The pronghorn is still, today, far faster than anything currently chasing it. The vegetation these animals moved through was open, but not uniform. This was a mosaic of grassland, sagebrush steppe, scattered woodland along the watercourses, and further north, spruce parkland where you would expect prairie today. Rivers running off the ice sheets carried enormous quantities of meltwater and sediment across the plains during warm intervals, cutting broad braided channels, and depositing the fine dust that would eventually become some of the most productive agricultural soil in the world. That is a connection worth sitting with. The wheat and corn belt of the United States exists partly because of Ice Age processes. Wind picked up fine glacial sediment and deposited it across the interior as a soil called less, in some places tens of feet deep. The reason the American Midwest can feed a large part of the world is that ice sheets ground rock into powder and the wind spread it across the plains, while mammoths and bison and horses walked over the result. The Ice Age wrote a great deal of modern America in this way, and most of it is invisible unless you know to look. The Great Lakes are glacial. The course of the Missouri and the Ohio was set by ice sheets diverting the drainage. Long Island and Cape Cod are piles of glacial debris. The rolling farmland of Iowa and Illinois sits on that wind-blown dust. The landscape Americans farm, drive across, and build on is, to a remarkable extent, a product of the same period that produced the animals in this account. Stand anywhere in the western Great Plains today, and the horizon is the most obvious thing about it. That was true then as well, but the horizon had animals on it. Not scattered pronghorn and the occasional distant pickup truck, but herds. The single hardest thing for a modern American to imagine about their own country is how full it used to be. We have a mental category for empty land and a mental category for developed land, and the Great Plains sit uneasily between them. But there is a third condition that this continent has not been in for 10,000 years, which is genuinely full. Land carrying its maximum load of large animals, with the grass cropped and the ground churned and the horizon occupied. That is what the American interior looked like, and no living person has seen anything comparable outside of a few protected corners of East Africa. Cross the Mississippi and everything changes. The eastern half of the continent was a different world in the Ice Age, and the animals in it were adapted to a different problem. Where the west was open, the east was closed. Spruce and pine forest, swamp, bog, dense undergrowth, and standing water. And the animal that defined it was not the mammoth, it was the mastodon. The American mastodon was shorter than the Columbian mammoth, standing around 10 feet at the shoulder, but longer in the body and far more heavily built. A low, stocky, powerful animal designed to push through timber rather than stride across grass. Its teeth were the giveaway. Instead of the flat grinding plates of a mammoth, it had rows of tall cone-shaped cusps, built to crush woody material. It ate branches, twigs, bark, pine cones, and shrubs. It was functionally a forest machine, and it had been in North America for something like 15 million years, far longer than mammoths. That length of tenure matters. Mastodons were not visitors to this continent. They were among its oldest large residents, established here long before mammoths crossed from Asia, before the modern Rocky Mountain drainage patterns formed, before the Isthmus of Panama closed. When the mastodon disappeared, North America lost a lineage that had been part of its landscape for 15 million years. How common were they? The numbers from a single state are startling. The bones of at least 140 mastodons and 18 mammoths have been recovered from New York State alone. Not a handful of celebrated specimens, but 140 individual animals from the ground of one state, and those are only the ones that fossilized, were found, and were recorded. If you live in the northeastern United States, the ordinary answer to whether elephants once lived where you live is yes, in numbers. And they keep coming out of the ground. Mastodon remains turn up during construction work, in drained ponds, in gravel pits, and in farmers' fields across the Great Lakes states and the Northeast with enough regularity that local museums in the region often have one. This is not exotic paleontology conducted in remote badlands. It is something that happens when somebody digs a pond in Michigan. Around them, the eastern forests held their own peculiar caste. There was the giant beaver, an animal the size of a black bear, up to 7 or 8 feet long, living in the wetlands of the Great Lakes region and the Northeast. It did not build dams as far as anyone can tell, but it was an enormous rodent in a landscape of ponds and bogs, and it lasted until the same extinction that took everything else. It is one of the animals people find hardest to accept, because a beaver is such a familiar and manageable creature in the American imagination. Scale it up to the size of a black bear and the mental image resists. But the fossils are unambiguous, and they come from exactly the states where beavers are ordinary today. There was the stag moose, a large deer with elaborate antlers unlike anything alive. There were giant ground sloths in the woodlands, tapirs, and peccaries. Predators in this closed country worked differently from the ones out west. Dire wolves were here, and so were jaguars, which had a far larger range than the now and grew larger than modern ones. There were black bears, and in places the short-faced bear. And Smilodon, the saber-toothed cat, ranged through the eastern woodlands too, an ambush hunter built for exactly this kind of terrain. Heavy in the front, powerful, designed to close a short distance and hold prey rather than run it down. This is a useful illustration of how the same continent produced different predator strategies in different terrain. Out on the plains, speed and endurance paid, and the American cheetah and the American lion reflected that. In closed eastern forest, where sightlines are short and everything is a surprise, the advantage went to animals built for a sudden, powerful, close-quarters attack. Smilodon was the specialist of that world. The forests themselves were not the ones standing there now. During the coldest stretches, spruce and jack pine covered much of the Midwest and the Appalachians, in a cold boreal forest that today sits far to the north. The hardwood forests we associate with New England and the Ohio Valley, the maple and oak and hickory, were pushed south, surviving in refuges in the southeastern states and along the Gulf. As the climate warmed, those trees migrated north again, and the modern eastern forest is largely a post-Ice Age arrangement, only a few thousand years old. That fact tends to unsettle people, because the eastern woodland is the American landscape that feels most ancient and permanent. Standing in an old-growth stand in the Appalachians, it is natural to assume you are looking at something primeval. In a sense you are, but the particular arrangement of species in front of you assembled itself relatively recently, as trees migrated north out of southern refuges at the end of the Ice Age, at speeds of a few hundred meters a year. And there is a detail here that most people never connect. Certain American trees produce fruit that no living animal properly eats. The Osage orange drops heavy green fruit that mostly rots where it falls. The honey locust carries long, sugary pods and vicious thorns high on its trunk, apparently defending itself against something that could reach far above your head. The most likely explanation is that these plants co-evolved with mastodons and ground sloths, which ate the fruit and spread the seeds, and when those animals vanished, the trees were left carrying out a contract with a partner that no longer exists. They are still producing fruit for ghosts. So the eastern forest, which feels like the oldest and most settled landscape in America, is in fact a recent arrangement missing most of its original cast. The trees are in the wrong place compared to the Ice Age, the animals that shaped them are gone, and some of the plants are still behaving as though the giants might come back. There is one more eastern absence worth naming, and it is the largest one. When European settlers described the forests of the Ohio Valley and the Appalachians as a great wilderness, they were describing a landscape that had already lost its elephants, its giant sloths, its saber-toothed cats, and its dire wolves several thousand years earlier. The wilderness that entered American mythology was not the original condition of the country. It was already a reduced version, and nobody who wrote about it knew that. Now go south and west, into Florida, along the Gulf, and across to California, because the warm edges of the continent held the strangest animals of all, and one place in Lowe's Angels has preserved more of them than anywhere else on Earth. Florida in the Ice Age was not the state you know. Sea levels were much lower, so the peninsula was substantially wider than it is today, and the climate was drier. Much of it was open savanna and grassland rather than swamp and pine flatwood, closer in character to parts of modern Africa than to modern Florida. The rivers of Florida are still producing the evidence. Fossil hunters and divers working the dark, slow rivers of the state pull up mammoth and mastodon teeth, giant sloth claws, glyptodont plates, saber-toothed cat bones, and enormous quantities of shark teeth, all mixed together in the sediment. Florida is one of the richest Ice Age fossil regions in the country, and much of it comes up out of the water. There is a reason for that concentration. Florida sits on porous limestone riddled with springs and sinkholes, and its rivers cut through sediments of many different ages, mixing material and then exposing it. Animals that died over hundreds of thousands of years end up in the same riverbed, which makes dating individual specimens difficult but makes finding them relatively easy. Divers working these rivers routinely surface holding a piece of the Ice Age, and it was full of animals that had come up from South America. That connection matters. Only a few million years earlier, the Isthmus of Panama had closed, joining two continents that had been separated for tens of millions of years and triggering the Great American Interchange. Animals moved in both directions, and Florida was the landing ground for the northbound traffic. Giant ground sloths came this way. So did glyptodonts, armored mammals the size of small cars with domed shells of fused bony plates, and in some species, a club-like tail. So did armadillos far larger than the ones alive today. And so, earlier, did a giant flightless predatory bird. That last one, Titanes, is worth a moment because it is such an unlikely arrival. Terror birds were the dominant predators of isolated South America for tens of millions of years, and only one of them ever established itself in North America. It reached Florida and hunted there, a 7-foot flightless bird with an axe-like beak, though it had disappeared long before the period we are describing. It is a reminder that the Great American Interchange sent genuinely strange things north, and the traffic in the other direction was heavier still. Cats, dogs, bears, horses, deer, and camels all moved south into South America, and the consequences there were dramatic. Many of the native South American mammal groups declined sharply after the northern predators and grazers arrived. The interchange was not a gentle mixing. It was a large-scale reshuffling of 2 continents' worth of animals, and Florida was the doorway. The ground sloths deserve their own moment because nothing alive prepares you for them. Today, a sloth is a slow, dog-sized animal that hangs in trees. In Ice Age America, there were several species of ground sloth, and the largest of them, Iremithurium, reached the size of an elephant and could rear up on its hind legs to feed from high branches, standing perhaps 17 feet tall. They had enormous curved claws and heavy bones. They were not predators. They were browsers on a scale that no living herbivore matches outside of elephants, and there were several species at once, occupying different sizes and habitats. Some were bulk browsers in open country. Others, like Megalonyx, were animals of the eastern woodlands and ranged remarkably far north. Ground sloths were not a single curiosity, but an entire successful radiation of large mammals, and their near-total elimination removed one of the most distinctive groups of animals the Americas ever produced. What survives gives almost no hint of what was lost. The tree sloths of Central and South America are small, slow, specialized canopy animals that persist by being inconspicuous. Their giant ground-dwelling relatives were among the largest land mammals of the Americas. To go from that to a dog-sized animal hanging quietly in a tree is one of the sharpest reductions in the recent history of any mammal group. Then California and the tar. Beneath what is now Central Los Angeles, natural asphalt has seeped to the surface for tens of thousands of years. Thin films of it collected under water and dust. Animals walked into it and could not get out, and predators came to the trapped animals and were caught in turn. The result is the single richest Ice Age fossil site in the world. The mechanism was slow and repetitive rather than a single dramatic event. Asphalt seeps to the surface most readily in warm weather, often collecting under a covering of water, dust, or leaves that made it effectively invisible. An animal walking through would find itself stuck in something with the consistency of glue. Only a few centimeters of it was enough to hold a large mammal. Researchers estimate that a single entrapment event every decade or so, across tens of thousands of years, would produce the quantity of bone that has come out of those pits. Hundreds of dire wolves, thousands of specimens of saber-toothed cats, American lions, short-faced bears, mammoths, mastodons, horses, camels, bison, ground sloth, birds by the tens of thousands. The ratio at those pits tells you something disturbing about the landscape. Predators vastly outnumber prey in the deposits because each trapped herbivore drew multiple hunters to their deaths. What that produces is an unusually complete census of the carnivore community of Southern California, and the community it describes is dense. Smilodon and dire wolves in enormous numbers, American lions, short-faced bears, coyotes, cougars, and a large scavenging bird community above them all. The birds deserve more attention than they usually get. Among the tar pit fossils are enormous condor-like scavengers with wingspans well beyond anything flying in North America today. Birds that made a living circling this landscape waiting for the carnivores to finish. A predator community that dense generates a great deal of leftover material. and an entire guild of large scavenging birds existed to work it. Because Lowe's Angels is where it is, this creates one of the strangest juxtapositions in American paleontology. The bones of the Ice Age are underneath a city of 4 million people, next to an art museum, across the street from traffic. School groups visit them. There is a working excavation in the middle of an urban park. Of all the places on this continent where the deep past is physically accessible, the most productive one sits in the middle of the second largest city in the United States. And across the whole southern belt, from Florida through Texas to California, the pattern repeats. A warmer, drier, more open landscape than today, carrying an extraordinary mixture of North American and South American animals that had only recently met one another, with a heavy predator load sitting on top. The southern United States was, for a few 100,000 years, one of the most biologically interesting places on the planet. And its animals came from two entirely separate evolutionary histories. The cats, bears, wolves, horses, and camels traced back through Asia and the northern land connection. The sloths, glyptodonts, and armadillos came up from a continent that had been isolated for tens of millions of years and had evolved in complete independence. For a brief geological moment, both experiments were running in the same country, and Florida and Texas were where they met. Step back from the map for a moment and consider the continent as a single system, because one thing about Ice Age North America stands out above everything else, and it is not the size of the herbivores. It is the number of predators. Assemble the list. Smilodon, the saber-toothed cat, roughly the size of an African lion but far more heavily built, with serrated canines nearly 7 inches long. The American lion, 25% larger than any lion alive. The short-faced bear, 30% larger than a grizzly. Dire wolves hunting in packs. The American cheetah, built for pursuit. Jaguars larger than modern ones. Cougars, gray wolves, coyotes, scimitar cats. And that is a single continent, at a single moment in time. It is also worth noting that these were not niche specialists carefully avoiding one another. Their ranges overlapped substantially, their prey overlapped substantially, and the fossil record repeatedly shows them turning up in the same deposits. This was not a tidy arrangement of separate territories. It was a crowded, contested landscape in which several very large carnivores were competing directly for the same animals. Modern ecology would predict instability from an arrangement like that. Competition between large carnivores is intense, and systems tend to settle toward fewer species with clearer separations. That this community persisted for hundreds of thousands of years tells you how much prey biomass was available. There was enough meat moving through the landscape to support redundancy at the top, which is close to the definition of an extraordinarily productive ecosystem. Compare that with Africa today, which we think of as the last stronghold of large predators. Africa has lions, leopards, cheetahs, hyenas, and wild dogs. Ice Age North America arguably had more heavyweight carnivores than that, and several of them were larger than anything hunting anywhere in the world now. The middle of the United States carried a predator community that has no modern equal, and that fact reshapes how you should picture every scene in this account. For a herbivore, this meant that there was no safe strategy. Speed helped, but the American cheetah was fast. Size helped, but the short-faced bear and the American lion were enormous. Cover helped, but Smilodon was an ambush specialist built for exactly that terrain. Group living helped, but dire wolves hunted in packs. Every defensive option a prey animal might adopt was already being countered by something, and the animals we see in the fossil record are the ones whose particular combination happened to work. Which raises a question worth sitting with. What did the failures look like? Evolution over hundreds of thousands of years produces a great many attempts, and the fossil record preserves only a fraction of them. The Ice Age herbivores we know about are the successful designs. There must have been many more that were not fast enough, not large enough, or not lucky enough, and most of them left no trace at all. This is one of the permanent limitations of working with fossils. and it is worth stating clearly whenever anyone, including me, describes an ancient ecosystem with confidence. What survives to be found is a small and biased sample, animals that died in the right place, in the right conditions, and whose remains happen to be exposed where somebody was looking. The Ice Age America we can describe is the part that fossilized. The real one was larger, messier, and more varied than any reconstruction can capture. You can see the marks of that pressure on the survivors. The pronghorn runs at speeds nothing on this continent can match, because something used to be able to. The bison retained size and mass and herd behavior. The tree sloths of Central and South America survived by being small and staying up in the canopy, while their giant ground-dwelling cousins were eliminated. These are not neutral traits. They are the residue of a competition that ended. It is one of the more haunting ideas in this field, and it goes by the name ecological anachronism, a living species carrying adaptations that make no sense against the world as it is and perfect sense against the world as it was. North America is full of these: the speed of the pronghorn, the thorns and fruit of certain trees, the wariness of some surviving animals. The continent is still in places, behaving as though the giants might come back. And there is a serious scientific idea attached to this, sometimes called Pleistocene rewilding, which asks whether introducing large modern animals could restore some of the ecological functions that were lost. It is genuinely controversial, and the objections are substantial. A modern elephant is not a mammoth. Ecosystems have moved on, and the risks of introducing large animals into landscapes that have adjusted without them are real. But the underlying observation behind the debate is not controversial at all. North America is missing a set of functions it used to have, and nothing has replaced them. The predators themselves were also competing with each other, and viciously. Fossil evidence from the tar pits includes healed injuries, broken and regrown bones, and damage consistent with animals fighting over food. When several large carnivores share a landscape, a kill is not the end of the contest but the beginning of it. A saber-toothed cat that brings down a young bison then has to hold it against dire wolves, and both of them have to consider what happens if a short-faced bear arrives. This dynamic, which ecologists call kleptoparasitism, is common in modern systems too. African lions routinely lose kills to hyenas and take kills from cheetahs, but the modern African version involves a handful of species. The Ice Age American version involved a much larger cast, several of which were heavier than anything in Africa today, operating in the same landscape at the same time. Look closely at the tar pit material, and the evidence of that pressure is physical. Broken and healed limb bones, skulls with puncture damage that closed over, jaws with signs of long-term injury in animals that clearly kept hunting afterwards. These were not comfortable lives. Even at the very top of the largest carnivore community this continent has produced, the individual animals were being injured regularly and were living with the consequences. There is a good argument that this crowding is exactly why the predators were so large. In a landscape where every meal is contested, size is the most direct currency there is. Being bigger means being able to take a carcass, defend a carcass, and dominate the animals that would otherwise take yours. The gigantism of Ice Age American carnivores was not a luxury. It was an arms race running among the hunters as much as between hunters and hunted. And all of it was sustained by the herbivores. A predator community that dense requires an astonishing amount of meat moving through the system beneath it, which brings us back to the central point about this continent. The reason North America could support that many large carnivores is that it was carrying an enormous standing population of large herbivores. Remove the base, and the whole structure comes down at once, which is precisely what happened. And it happened quickly enough that the predators had no opportunity to adapt. A carnivore community built over hundreds of thousands of years around an abundant supply of very large prey does not have an alternative strategy waiting. When the mammoths and horses and camels and ground sloths went, the animals that ate them followed almost immediately. The tar pits capture this. The great predator deposits stop at the same horizon as their prey. Beginning somewhere around 15,000 years ago and largely finished by about 10,000, North America lost its giants. The scale of it is difficult to overstate. At least 32 genera of megafauna disappeared, along with several smaller genera, adding up to more than 70% of the continent's large animal genera. 30 of those genera went globally extinct, meaning they did not simply vanish from North America, but ceased to exist anywhere. Researchers who study it compare the event, without exaggeration, to the extinction of the dinosaurs. The comparison holds in one specific and important way. Both events removed the large-bodied animals almost completely while leaving the small ones largely intact. After the asteroid, the surviving mammals were mostly small. After the Pleistocene, the surviving North American mammals were mostly small. Being big in a crisis is close to a liability. Large animals need more food, more space, and breed too slowly to recover from a sharp population decline. Everything in this account went. The mammoths and mastodons, the ground sloths and glyptodonts, the native horses and camels, the American lion, Smilodon, the short-faced bear, the dire wolf, the American cheetah, the giant beaver, the stag moose. The bison survived in reduced form. The pronghorns survived. The bears and cougars and wolves survived. Almost everything else above about 100 pounds did not. And it is worth listing what that means in practical terms for the continent today. North America has no native elephants, no native horses until they were reintroduced, no native camels, no large cats above the cougar, no bears larger than the grizzly, and no wolves heavier than the gray wolf. Every one of those categories was occupied 20,000 years ago, several of them by more than one species. Why is one of the longest-running arguments in the field, and the honest position is that it remains unresolved. Two explanations dominate. The first is climate. The end of the Ice Age brought rapid warming, the collapse of the mammoth steppe, the reorganization of vegetation across the continent, and around 12,800 years ago, an abrupt cold snap called the Younger Dryas. The second is people. Humans arrived and spread across the continent within the same window, hunting large, slow-breeding animals that had no experience of a predator like us. That last clause is doing real work in the argument. Animals in Africa evolved alongside hominins for millions of years and had time to develop appropriate wariness. Animals in the Americas met a fully modern, tool-using, cooperative human hunter with no evolutionary preparation whatsoever. The same pattern shows up worldwide. Wherever humans arrived late, large animal extinctions tend to follow soon after, and the correlation is difficult to dismiss. Most researchers today favor some combination, and the interesting scientific work now lies in disentangling how much each factor contributed, where and when. But there are pieces of evidence worth knowing, because they cut in different directions. In the Northeast, a substantial majority of the megafauna appear to have been gone before humans were on the scene at all, which points strongly at climate. Meanwhile, on Cuba and Hispaniola, ground sloths survived thousands of years longer than on the mainland, and then disappeared right at the point when humans first reached those islands, about 4,400 years ago. That timing is very hard to explain with climate. The Caribbean case is particularly valuable precisely because it separates two things that are otherwise hopelessly tangled. On the mainland, humans arrived and the climate warmed at roughly the same moment, which makes the two causes almost impossible to distinguish. On those islands, the climate change happened thousands of years before the humans did, and the sloths sailed straight through it. Then people showed up and the sloths went. It is about as close to a controlled experiment as this subject ever gets. The same pattern appears elsewhere in the world, which strengthens it further. Madagascar, New Zealand, and various Pacific islands all lost their large animals shortly after people arrived, in each case thousands of years after any relevant climate shift. Islands are the natural laboratories of extinction because they isolate the variables that the continents tangle together. The cleanest reading of the whole picture is that both are true and neither alone is sufficient. A warming, reorganizing continent put enormous stress on animals adapted to a cold, dry world, fragmenting their habitats and thinning their populations. Into that already unstable situation came a new predator, and for large animals that produce few offspring over long lifetimes, even modest sustained hunting pressure can push a declining population past recovery. Extinction rarely requires a massacre. It requires deaths to outpace births persistently for long enough. What followed was not simply an absence. It was a transformation. When you remove every large herbivore from a continent, the vegetation responds. Studies of pollen records show woody and leafy plants increasing after the megafauna disappeared, in patterns that climate alone does not explain. Without mammoths knocking down trees, without vast herds cropping grass and trampling seedlings, forests thickened and grasslands shrank. The continent did not just lose its animals, it grew a different skin. And that change is still running. Ecologists who study this argue that many North American landscapes remain out of equilibrium, still adjusting to the absence of animals that disappeared thousands of years ago. Forests that would have been kept open are closed. Seeds that would have been dispersed across 100 miles now fall beneath the parent tree. The extinction is not a finished event in the past. It is an ongoing condition that the continent is still living inside. Fire changed as well. Large herbivores consume enormous quantities of plant material, and when they disappear, that material accumulates instead. Charcoal records from several regions show increased burning after the megafauna losses, which is precisely what you would expect when nothing is left to eat the fuel. Removing the animals changed how the continent burned, not only how it grew. Some of the last of them held on in strange places. On Wrangel Island in the Arctic Ocean, a small isolated population of woolly mammoths survived until roughly 4,000 years ago, which means mammoths were still alive while the pyramids of Egypt stood finished. On the Caribbean islands, ground sloths persisted for thousands of years after their mainland relatives were gone. The Ice Age did not end everywhere at once. It retreated into corners, and then those corners closed. And what remains is the continent you live on. It is a beautiful place and a rich one by modern standards, but by the standards of 20,000 years ago, it is a depopulated version of itself. Every state in the Union is missing most of its large animals. The elk and deer and bears we treasure are the survivors of a much longer list. When Americans talk about their wilderness, they are talking about the quiet that followed. None of which is an argument for despair, and it is worth saying so plainly. The animals that did survive here are magnificent. Bison still move across parts of the plains, grizzlies still fish Alaskan rivers, wolves have returned to Yellowstone, and pronghorns still run at speeds nothing can match. What the deep past offers is not guilt but perspective, an accurate sense of how much this continent once held, and therefore how much what remains is worth. The strangest part of everything we have covered is how recently all of it happened. 20,000 years, if you think about the age of the Earth, really is a short stretch of time. While these animals were living and hunting on the American continent, people on the other side of the world in Europe were busy painting on cave walls. The last surviving mammoths were still alive, while people were building structures out of stone. This is not the distant world of the dinosaurs. It is the history of animals that once lived in the ground beneath our feet. That is why we keep finding what they left behind. Mastodon bones come out of fields in Ohio and construction sites in New York. Mammoth footprints are still pressed into the ground at White Sands. In Lowe's Angels, the tar seeps are still giving up the remains of saber-toothed cats. Somewhere within a few hours of where you are sitting right now, there is ground holding the remains of an animal that would astonish you. So I have a question for you. Did you know about the lions, the elephants, and the camels that once lived in America? And which of them lived in the state where you live? Tell me in the comments below.